Okay, welcome to our next lesson. So in this lesson, I want us to look at form validation. Uh, Let me say that the validation that we'll be doing will be sort of crude. Um, Ideally, we would want to tell the person uh, which of the fields uh, they need to re-enter the value, and the fields that have correct values, we want to repopulate those fields so that the person does not have to retype everything in the form. But before we get to that, let's start and do something basic. All we want to do is to check if the fields the fields in the web form, if they're empty. If they're empty, we want to provide some message. And also we want to ensure that the fields are of a specific length. So we don't want the fields to have infinite length. Okay. So the first question is, where do I check the web form? Where do I check the fields? Well, we would check it right here after we have parsed the form. So I got the form fields, and so since I have the form fields, I want to now check them to make sure that they are actually valid. And so I will check the web form fields for validity. Okay, so I will create a map which I will use to link the field with whatever error message I want generated. So I'm going to create a map. Okay, and if you recall from your programming course, a map is simply a structure that has a key and has a value attached to it. Okay, so in Go, we say map, and in square brackets, we specify the type of the key, which is string. And right beside it, we specify the type of the value, which is also string. And so I will use this map to store my errors and which field those errors belong to. Okay, so let's actually do the part that is for this lesson. Let's check each field. Okay, and I'm going to start off with the author field. So if the author field, okay, no, let me not do that. Let me tell you what I'm going to do. I want to first check to see if the field is empty. And the way we do that, we want to trim any space that is present. All right, so we want to remove any empty spaces. And then we want to use the Go function trim space, which allows me to check the field after I have trimmed it to see if it's actually empty. So I'm going to use the strings package, okay, and there's a function called trim space, okay. And it basically removes all spaces at the front, all spaces at the back, right? We don't want those spaces. And once I have done that, so author, okay, so author, the author box, the author field, we'll have all the leading and trailing spaces removed. And so if, after I've done that, if I find out that author is actually empty, then I have to provide an error message. And so I will say errors, and the key will be author, okay, and the value will be this field cannot be left blank. All right. Now, if we find out that there is something in the field, we want to check to see if it has the appropriate length. And so I want that the author field, whatever the person types in, cannot be more than 50 characters. All right. And so I will say else if, okay, and so I need to find out how many characters the person typed in. And so to do that, I will use the UTF-8 library package. And this package has a function called rune count in, okay, wait, count C-O-U-N-T, okay, in string. And so what it will do, it will count the number of characters. Okay. Now you might be thinking you could use the len function, but you can't, because the len function counts the number of bytes, which will not always be the same as the number of characters. All right. So to count the characters, we use rune count in string. And we want to count author. Now, if after counting, the answer returned to us is greater than 50 characters, then I want to provide an error message. Okay, so errors in the author field, and it will be this field is too long. And then I will say something like maximum is 50 characters. Okay. All right. Let's close that. All right. Good. Let's close that. And that takes care of the first one. All right. So if it's empty, we say this field cannot be left empty. If it's not empty, we then check to see how long it is. And if it's greater than 50, then we display that message, or we store that message in our map. Now, we're going to repeat the same thing for the other two fields. So to save time, I will copy and paste. However, I need to be very careful that I actually replace the right things. So if strings that trim space category, okay, is empty, then I want to save in category this field cannot be left blank. And if it's not blank, then I want to check to see if check the length. So for category, I want the maximum length to be 25. Okay, and so I need to make sure I change this to category. Okay, and if category is more than 25, I'm going to say this field is too long. Maximum is 25 characters. Okay, and then I do the same for the quote field. So I'm going to check quote. Okay, I'm going to trim any leading or trailing spaces. And then I'm going to say if it's empty, then I'm going to store in the map as the key quote the value this field cannot be left empty. Good. And then I need to check the length of quote. And if it's more than 255 characters, now these numbers are arbitrary. I am choosing them just because that's what I want. Of course, the length is dependent on what the application is meant to do. Okay, so these numbers will vary. Let me change this to quote, and I will say that it's too long. It has to be 255 maximum. Okay, so I have my checks in place. So what I want to do now, I want to check if there are any errors in the map. Okay, so assuming there were errors, then this errors map will have a length greater than 0. If there are no errors, then this map will be empty. Okay, so I'm going to say if, I'm going to use len. Okay, all right, it takes a type. So notice it could take a map. Okay, and it will return 0 or not. Well, it will tell me if it's empty or not. So if the length of our map, which is errors, is greater than 0, which means it's not empty, which means that there was some error, all I'm going to do is display that to the user. So I'm going to say fmt dot, let's use fprint. All right, so fprint takes an IO writer. Our response writer is an IO writer. So we'll just pass W and we'll pass the map. And so what will happen? Fprint will simply display the map for us on the web page. Okay. Now, assuming that there are no errors, then we will come down here. So clearly, if there are errors, I don't want to continue executing the rest of this code. So as we know by now, what we do is we return. Okay, so we leave the handler function. And that looks about right. So if there are errors, we just leave. If there are no errors, all of this will be skipped, and then we will proceed to inserting the data. So it's pretty much straightforward. So let's open a new terminal, and let's run our code. Okay, let me open my browser, localhost. Okay, and let's go to quote. Okay, and if let's say I submit something for my name, let's say I use a category that's larger than 25. Say hi. Let's say I leave this empty and I submit. Alright, so it will tell me a category longer than 25 and quote cannot be empty. So this is the map, this is the key, and this is the value. This is the key, this is the value. Okay, so obviously if we do it right by saying maybe life, say go all in or none at all. Okay, and notice there are no errors because everything checked out. Okay, so again, let me stop my browser. Okay, all we did was to check the fields for errors. If there was no input, if the input was too large, we displayed the error to the user. Now, obviously, this is not the way it's done, where we actually display the map to the user. What we tend to do, right, is we redisplay the form, okay, and anything that's missing or is incorrect, we would display some message such as this field cannot be blank, or this field cannot be larger than 25. And anything that was good, all right, we want to keep it. Okay, so go all in or none at all. Okay, so this is good. So we want to keep this. We don't want the user to have to type it again. So we only want to specify that maybe this was not good. So in red, maybe you need to change that. This is good, so we keep it. All right. So that's what we want to do. So for us to do that, we have to keep track of the good data so that we can repopulate the form with the good inputs. And we also want to use our errors map so that we know which field to write the error message on. Now, we want to pass all of this information. Right? So we need to pass the errors map in our template. Okay, in our template. Okay, because we want to redisplay the form. So we want to redisplay our form. Where is it? Where is my quote form? Okay. I'm missing a handler. Where is my? I'm missing. Oh, I'm missing. Yeah, right here. So we want to be able to redisplay the form, okay, by calling this again. However, we want to ensure that the template has the error message map and it has a copy of the data that was correct in the fields so that we can repopulate those fields. All right. We want to pass all of that to the execute function on our template so that it can incorporate all that data into our form if the user has to re-input stuff. Now, that's what we want to do. That's how it's done. Now we have a slight problem though, because if we try to pass the data and the map, right, in addition to anything else, right, then I already have two things that I want to pass and give to execute, right? So I want to give execute two pieces of data, all right? However, if you look at the function signature of execute, right? If you look at the function signature of execute, right? It will say that execute gets the IO writer, no problem, and it gets a second argument. It gets a second argument, which is a data, right? We passed in the quotes slice. Great. I can't pass anything else to this execute function because it would violate its signature. It only accepts two pieces of data. So the problem is I want to pass, right? If I go back to my function here, I need to pass this errors map to execute. I need to pass the data to execute. But if I do that, that's now three things that execute will have in it, which is not possible. All right, so I cannot pass three things into execute. It just will not allow me to do that. So if I want, let's say I wanted to do something like quote again. All right, what quote? Sorry. All right, it's too many arguments. Too many arguments. So I have a sort of problem. How am I going to pass all of this data to execute, given that execute only accepts one piece of data? All right, so I need to pass the errors map. I need to pass the actual data, right? What the user entered. Those are two things. I have a limit of one. So it turns out that we will have to refactor our code. So notice I bring up the term refactor again. Remember the first time we refactored, that was when we took the function handlers out of main and we brought them into their own file called handlers. Okay, that was the first refactoring we did. So whenever you're building any software, you just write your code, and when you realize that it's starting to get a bit compact, it's starting to get a bit crowded, you're not able to expand it or extend it or to let it do what you want, then you have to stop and then you have to refactor the code, which is just a fancy way of saying you need to sort of clean up the code, move things into their own files, try to make things a little bit more abstract, right? And an analogy of this would be when you started learning how to program, you wrote everything in main, and then later on you learned about functions, and you decided to take your code and you broke it up into functions, all right? And you simply called the functions that you needed from main. And so all main does is call functions that you have created elsewhere. So that's an example of refactoring. So to accomplish our goal, right, we basically hit a wall where the way we have been writing our code is not allowing us to do what we want to do, which is to provide feedback to the user as to which of the fields is incorrect, and so prompt them to re-enter it, while at the same time leaving what they did enter correct in the field so that they do not have to retype those. And so in the next coming lessons, we will refactor this code so that eventually we are able to only pass one piece of data which will contain the other pieces. So if you think about it from now, we probably have to make some kind of struct, and that struct will have different fields, which basically will include other structs. All right, so that's what we will end up doing, passing in a struct which contains the other pieces of information. It contains the user information, it contains the error map, and any other information that is needed. All right, so I hope that made sense. Again, we started off by doing a simple form validation. However, we realized that we cannot extend it easily, and so we need to do a bit of refactoring, and that's what we will set out to do in the next coming lessons. I'll see you in those.